Good morning, students. Welcome to Organic Natural Products class. This is Chandravati. You are learning about Taxol. In this class, you are learning about Taxol occurrence, Taxol uses, and structural elucidation of Taxol. Taxol. Taxol occurrence and uses. Taxol is isolated from bark and stem of Taxus brevifolia. Taxol is isolated from stem and bark of the Taxus brevifolia. Uses of Taxol. Taxol have anti-leukemia activity and it also have anti-tumor activity. It have an excellent anti-cancer activity. It have an excellent anti-cancer activity. It is used in the chemotherapy of lung cancer, breast cancer and melanoma cancer. It is used in the chemotherapy of lung cancer, breast cancer and melanoma cancer. It is also used for the treatment of AIDS infected sarcoma. Although Taxol have many uses in chemotherapy, but there is a side effects for this like hair loss and peptide loss. The side effects are hair loss and peptide loss. Constitution of Taxol. Constitution of Taxol or structural elucidation of Taxol. This is the structure of Taxol. This is the structure of Taxol. Taxol have molecular formula of C47, H51, O14, N. So, Taxol contains 47 carbon atoms, 51 hydrogen atoms, 14 oxygen atoms and 1 nitrogen atom. The nitrogen atom in Taxol is in the form of amide and it is an unsaturated compound because it have CC double bond. So it is an unsaturated compound. It have amide functional group and it also have hydroxy functional groups, acetoxy functional groups and benzoxy functional groups. And also it have ketonic functional group also. Basically, Taxol have 47 carbon atoms, but on thermal decomposition, it forms only 4 isoprene units. On thermal decomposition, Taxol forms only 4 isoprene units. So, it is an diterpenoid and it have 3 rings in the structure. It have 3 main rings in the structure. So, it is an tricyclic terpenoid. So, let us name the circles or rings. It have 9 asymmetric centers. Taxol have 9 asymmetric center and it is a levorotatory compound. It is a levorotatory compound. On mild hydrolysis with methanol, and hydrogen, it forms tetrol. On mild hydrolysis with methanol and hydrogen, it forms a tetrol, which contains the basic skeleton structure of Taxol and 4 hydroxy groups. A tetrol which contains 4 hydroxy groups and basic skeleton structure of the Taxol. Taxol basically contains 3 rings in the structure. They are ring A, ring B and ring C. So Taxol contains ring A, B and C. The ring A is a 6-membered ring and ring C also is a 6-membered ring, but ring B is an 8-membered ring. So A and C in the Taxol have 6 rings, 6 carbons in the ring, and B have 8 carbons in the ring. The structure of Taxol is elucidated by using spectral data. The structure of Taxol is elucidated by using spectral data. Taxol contains free hydroxy groups 4. Taxol contains 4 hydroxy groups in the structure. So, the proton on oxygen atom gives a signal at 4.9 delta. The proton on oxygen atom gives a signal at 4.9 delta. In the NMR spectra, the hydrogen attached to the oxygen shows a signal at 4.9 delta, which is a singlet for this hydroxy group. And this hydroxy group shows a doublet at 4.9 delta because it have one proton on adjacent atom. So the proton on oxygen shows a doublet at 4.9 delta, and this hydroxy group also shows a doublet at 4.9 delta in NMR. The proton on nitrogen atom in amide group shows a singlet at 5.0 to 8.05 delta. The proton on nitrogen in amide group shows a signal in between 5 to 8 delta, and the protons in the benzene ring shows a singlet at 7.3 delta. The protons in benzene ring all are equivalent protons. So these proton shows a signal at 7.3 delta. Similarly, the protons in this benzene ring also shows a single signal of singlet at 7.3 delta. Similarly, the protons in the benzene ring of benzoxy group shows a singlet at 7.3 delta. So, the Taxol contains total 3 benzene rings, and each benzene ring contains 5 protons. For these 5 protons, they will show a singlet at 7.3 delta. Next, protons in methyl group. Taxol contains total 4 methyl groups in the structure. It contains 4 methyl groups in the structure. Let us see where the methyl groups form signal. The methyl group attached to vinyl carbon shows a singlet at 2.3 delta, and the protons attached to carbonyl carbon shows a singlet at 2 delta, and the protons on methyl group shows a singlet at 1.0 delta, and the 6 protons for these 2 methyl groups shows a singlet at 0.1 to 1 delta. Next, the protons attached to the basic skeleton structure. The proton attached to the ring B shows a signal of singlet at 4.8 delta, and the proton shows a signal triplet at 4.5 delta, and the 2 protons attached to ring C shows a triplet at 1.5 delta, and the proton shows a triplet at 4.4 delta, and the 2 protons shows a singlet at 4.0 delta, and the proton which is attached to bridgehead carbon of ring B and C shows a signal at 1.1 delta, which is a doublet, and the proton attached to 8-membered ring shows a doublet at 1.5 delta, and the 2 protons of ring A shows a doublet at 1.2 delta, and the proton which is present on adjacent carbon of nitrogen shows a triplet at 2.6 delta, and also the proton on adjacent carbon to before hydrogen shows a doublet at 4.3 delta, and the hydrogen attached to ring A shows a triplet at 4.5 delta. This is the spectral data of Taxol. By using this NMR spectral data and also by using C13 NMR and mass spectroscopy, the total structure of Taxol was elucidated. This is the structure of Taxol. So, in the next class, we will discuss about the synthesis of Taxol. In the next class, we are discussing about synthesis of Taxol.